Algebra 2, here we are with our 5A formative or quiz review. Given the roots, write the polynomial function, emphasis on function, make sure we have f of x equals, in standard form. X is -2 and x is 4i. Remember, i's happen in pairs, so if we have positive 4i, you also have negative 4i. What parentheses groups would these have come from? X plus 2, x minus 4i, and x plus 4i. Whenever we have imaginary parts, we're going to multiply those imaginary parts first. We're going to have x times x for x squared plus 4ix minus 4ix, and then negative 16i squared. Plus 4ix minus 4ix will cancel out. Remember that I squared equals -1. So negative 16i squared, that's negative 16 times -1, we'll flip that back to positive 16. And now I'm going to bring down the x plus 2, and we'll multiply those together. X times x squared will be x to the third, plus 16x, plus 2x squared, plus 32. And for our final answer, we'll rearrange, and don't forget to put f of x equals, and rearrange and put it in terms of the correct order, the biggest exponent down to the smallest. X to the third plus 2x squared plus 16x plus 32. Next problem. Graphing f of x and labeling all the coordinates of all these special points. So, typing this into the calculator, we have y equals x to the fourth, x, power button, 4, arrow down, plus x to the third, arrow over there, minus 4x squared, plus x plus 2. Graph. And we should have a little squiggly x to the fourth graph. Okay, relative max. All of these things are probably going to come from the same area, second trace. Second trace gets us to the calculate menu. We want relative max. Okay, this is the same procedure for basically everything out there. Okay, you're going to move your little blinky cursor and get it as close to what we're looking for as possible. So the maximum, the top of the little hill there, that's about as close as I can get. It will always ask for the left bound, not up, not down. Okay, always left first and then the right boundary. So we're going a little bit to the left, and then we go back up to the top, and we go a little bit to the right. You hit enter again for your right boundary, and then your guess, your third click is back on top. 0.13, 2.06. Okay. We'll do our best here. 0.13 is barely off the axis. 0.13 over, 2.06 up. We're talking somewhere in there. Okay, if you want to be really good, we should label these. 0.13, 2.06. Minimums, relative minimum. We're going to have 2 of them. Boom, boom. Okay. Second trace, minimum. I'm going to go left side first. We're going to scoot all the way down to the bottom of that valley. Left, left, left. Enter. back down to the bottom, right, enter, back down to the bottom, and enter a third time to guess. And our minimum is negative 1.88, comma, negative 8.17. Negative 1.88, comma, negative 8.17. And we'll do our best. Negative 1.88, negative 8.1, 1, 2, 3, 4, 5, 6, 7, 8. Negative 1.88, comma, negative 8.17. Another minimum, just a little itty bitty one up there. Second trace minimum. Okay, get to the bottom of that hill. And we do the same thing. Left, enter. Back down to the bottom. Right, enter. Back down to the bottom. And guess. Ooh, this is a good one. 1.00000007, comma 1. If you get 1 or something with a bunch of zeros and then a random number at the end, just go with the whole number. Okay, in class today we had 0.999999999. Okay, just call that 1. Alright, if it's a bunch of like zeros or nines, just round it. If it was like 1 9, not good enough. But when it's like 6 9s in a row, then yeah, we can round it to 1 1. Okay, y-intercept, I don't need the calculator, neither do you. Because y-intercept always happens at 0 comma something. Okay, and if I plug 0 in, 0 plus 0 minus 0 plus 0 plus 2. The y-intercept should be that last number. 0 comma 2. Which didn't really help us out a whole lot because it's right next to it, that little maximum we had. Zeros crossing the x-axis. It happens 2 times. Second trace 0. And we're going to scoot our guy all the way over there. Now zeros do get a little tricky. They can be kind of visually deceptive because it's pretty steep and the cursor is going to jump pretty quick with every click. So you got as close as I can. Left bound. I'm going to click left like 2 or 3 times. 1, 2, 3. And I'm off the screen. That's okay. You can still hit enter. And now we're going to come back down. 1, 2, 3 to the right is going to slide me down. I still need to go 3 more to the right, 2 or 3 more to the right. And hit enter. And now back over. Enter the third time. We're at negative 2.58, comma 0. Negative 2.58, comma 0. Alright. Go ahead and push pause and try to get that other one on your own. Go ahead and push pause. Try to do that other one on your own. Let's see if you're able to do that other one on your own. Second trace 0. We're going to scooch our guy all the way over there. Okay. We get as close as we can, and it's always left. Now, sometimes it's confusing because the left moved up on this side, but it's going to move down on this one. Don't think about it in terms of up and down. Think about it as on the graph, moving left and right along the graph. So left bound, left, enter, back to our 0, right, enter, back to our 0, and guess we have negative 0.58. It's going to round to negative 0.58, comma 0. Oops, that's probably not a good spot for it, but whatever. Okay. And that takes care of all of those. Now, Mr. Handke also likes you to add any perfect points. So I'm going to push second, graph. That'll take us to the table. And we're going to look around for any nice perfect points that fit on the graph. Okay, so -2, -8 would fit on our graph. It's pretty close to this minimum we have, so it doesn't really do much for us in terms of shaping our graph. -1, -3 is kind of nice. 1, 2, 3 fills a bit of an empty space there. 0, 2, we already had that for the y-intercept. 1, 1, we already had that for one of our minimums, I think. And then 2, 12 goes off the graph, but it's also not terribly far off the graph that we could kind of guess, like there's 10, 11, 12, just to give it some extra shape. If you did not do that on a test, I would not be worried about it. Okay? So we should be looking like this. Alright, pretty steep. Down, up. I'm a little wobbly there. And back up we go. Not too bad. A little wobbly in that middle part, but otherwise not too bad. Okay, domain, we are going left and right forever, so that'll be all real numbers. Range, you do have to think about. If we had one arrow going up and one arrow going down, then our range would be all real numbers. It's not split. Both arrows are going the same direction, which means we're going to have a high point or a low point. This is as low as we get. Both arrows are going up, so we'll never be able to reach the top, but this is as low as I can get. So I know that my y's are all the rest of my y's are greater than or equal to -8.17. Okay, that one takes a little bit of time. The first problem, not too much time. Second problem does take a little bit of time, a lot of little details, a lot of little decimals. You can do it though. You can do it. Okay, graphing a relatively friendly square root. This is relatively new, but so inside controls left and right, and it's opposite of what your brain wants to think. So +3 is actually going to go backwards 3, and -2, the outside goes up and down, and it's normal of what your brain wants to think. So our starting point is 1, 2, 3 back, and 1, 2 down. And I'm going to label this one just because usually we don't label perfect points, but I'm going to label this one because it's very closely related to our domain and range. Okay? And then with no multiplier on the inside, you should be able to do this with your brain. It's a square root function. Our first perfect square is 1. So if I go over 1, the square root of 1 is 1. Go up 1. Our next perfect square is 4. 1, 2, 3, 4. And the square root of 4 is 2. So up 1, 2. And that's the minimum you would need to graph this. Starting point plus 2 more. I'd really like you to do 1, 2, 3, 4, 5, 6, 7, 8, 9. Up 1, 2, 3. Okay. And we're going up and out. Remember that square roots have a definite start. We don't keep going forever both ways. We start here and go up and out. Or in this case, the negative is going to go down. Okay. So domain, x is x-coordinate, greater than or equal to -3. Range, right off the y-coordinate from our start. We're going up, so they're greater than or equal to -2. Multiplier on the inside. This is pretty new. We're going to take the inside, we're going to set it equal to 0. X equals -3/2. That's going to be the x-coordinate of our start. -1.5 or -3/2. And then the y-coordinate is still that -3. So we're at -1.5, -1, 2, 3. That's where we're starting. Okay. Now, the points pattern for this gets a little crazy. So we talked about just using our calculator to steal 2 nice points. Hopefully there's 2 nice points. If there's not 2 nice points, then do the best you can. So y equals, don't forget that times 2 on the outside. second square root. That's going to come from second x squared. Gets us our square root. 2x plus 3. Okay, now to end the square root, you could do a closed, depending on what calculator you have, you're going to do a closed parenthesis. Or for this calculator, you're going to arrow out to get out from underneath. And then minus 3. We're going to hit graph so we can see the picture, so we can kind of verify I'm in the right ballpark here for my start dot. And then we're going to go second table, second graph takes us to the table, and we're going to look for some nice ones. And this one does give us a couple nice points. We got -1, -1. We have 3, 3. So it is nicer that it gave us those. I mean, it could also go out to 11, 7, but okay, so we're going to take those. We need the start point plus 2 more. Okay, our domain, x's are greater than or equal to -1.5. And our range, our y's are greater than or equal to -3. Okay, can't promise that they'll always be nice. Sometimes you just might have to pick 2 points. Don't pick them right next to each other. Spread them out a little bit. You might have to pick 2 points and then round them and label them on the graph. And our last one, f of x equals the square root of x, is translated 3 units up and 4 units to the left. Okay, so, and it wants it in function form. F of x equals, I'm just going to put a square root here with x. Up 3. Up 3, remember up and down is controlled on the outside, and that's normal of what your brain wants to do. So up is a plus 3 there. Left is on the inside, left and right is on the inside of x, and it's opposite. So left, we're going to the negative side. It feels like we should do -4, but it's actually going to be opposite. We're going to do +4. And there is your equation. All right? We should have time to discuss this before we take the quiz or formative assessment or first try or whatever you want to call it tomorrow, and answer any of your questions there. Also see the answer key posted to Schoology or probably included in an email. Thanks for watching and good luck.